overview. This module. Hello, and welcome to AWS Cloud Foundations Module 1. This is called Cloud Concepts Overview. This module addresses the following topics: introduction to cloud computing, advantages of cloud computing, an introduction to Amazon Web Services, and the AWS Cloud Adoption Framework. In addition to this video, there's going to be a knowledge check that will be used to test your understanding, the key concepts that are covered in the module. After completing this module, you should be able to, number one, define the different types of cloud computing. Number two, describe the 6 advantages of cloud computing. Recognize the main AWS service categories and the core services. And finally, review the AWS Cloud Adoption Framework. We're ready. Let's get started. Hello, and welcome. This video will cover an introduction to cloud computing. What does cloud computing mean to you? Take a moment. Think what cloud computing means to you. Welcome to an introduction to the foundational database services that are available on AWS. AWS solutions typically fall into one of two categories, unmanaged or managed. Unmanaged services are typically provisioned in discrete portions as specified by users. As the owner of the service, you manage how the service responds to changes in load, errors, and situations where resources become unavailable. If you want to maintain complete control of your database, you can install a relational database management system on an Amazon EC2 instance. This will be very similar to running your database in a physical data center that you own and will be an example of an unmanaged service. Say that you launch a web server on an EC2 instance. Because Amazon EC2 is an unmanaged solution, that web server will not scale to handle increased traffic load or replace unhealthy instances with healthy ones unless you specify that it use a scaling solution. It could be the auto-scaling service that you use. The benefit of using an unmanaged service is that you have a more fine-tuned control over how your solution handles changes in load, errors, and situations where resources become unavailable. There is also some configuration for managed services. For example, you can create an S3 bucket and then set permissions for it. However, managed services typically require less configuration. Now we will look at the challenges of running an unmanaged standalone relational database. Then you will learn how Amazon RDS addresses these challenges. When you run your own relational database, you are responsible for several administrative tasks, such as server maintenance, energy footprint, software installation and patching, and database backups. You're also responsible for ensuring high availability, planning for scalability, data security, and operating system installation and patching. All these tasks take resources from other items on your to-do list and require expertise. To address the challenges of running an unmanaged standalone relational database, AWS provides RDS, a service that sets up, operates, and scales relational databases without any ongoing administration. With Amazon RDS, your primary focus is your data on optimizing your application. With Amazon RDS, you manage your application optimization. AWS manages installing and patching the operating system, installing and patching the database software, automatic backups, and high availability. AWS also scales resources, manages powers and servers, and performs maintenance. Offloading these operations to the managed Amazon RDS service reduces your operational workload and the costs that are associated with your relational database. Let's take a closer look at the details of RDS. The basic building blocks of the Amazon RDS is the database instance. A database instance is an isolated database environment that you can contain multiple user-created databases. You can access your databases using the same tools and applications that you use with a standalone database instance. When setting up your database, you pick an instance class and the type of storage you need for your database. Database instances and storage differ in performance characteristics and price. This enables you to customize your performance and cost to the needs of your business. When you choose to create a database instance, you specify which database engine to run. Amazon RDS supports 6 database engines: MySQL, Amazon Aurora, Microsoft SQL Server, PostgreSQL, MariaDB, and Oracle. There are many different ways to configure your RDS implementation. For example, you can run an instance in an Amazon VPC. When you use a VPC, you have control over your virtual networking environment. You can select your own IP address range, create subnets, and configure routing and access control lists to control access to your database. The basic functionality of Amazon RDS is the same whether or not you run it in a VPC. Usually, the database instance is isolated in a private subnet, and it's only made directly accessible to the applications that you choose. One of the most powerful features of Amazon RDS is the ability to configure your database instance for high availability with a multi-AZ deployment. When you configure a multi-AZ deployment, Amazon RDS automatically generates a standby copy of the database instance in another availability zone within the same VPC. After seeding the database copy, transactions are synchronously replicated to the standby copy. Running a database instance in a multi-AZ deployment can enhance availability during planned system maintenance, and it can help protect your database instance if there is ever a disruption within the availability zone. If the main database instance fails in a multi-AC deployment, Amazon RDS automatically brings the standby database instance online as the new main instance. The synchronous replication minimizes the potential for data loss. Because your application references the database by name by using the DNS domain endpoint, you don't need to change anything in your application code to use the standby copy for failover. Amazon RDS also supports the creation of read replicas for MySQL, MariaDB, PostgreSQL, and Amazon Aurora. Updates that are made to the source database instance are asynchronously copied to the read replica instance. You can reduce the load on your source database instance by routing read queries from your applications to the read replica. This is a configuration that you will choose if you have an application with a high number of read operations. Amazon RDS is a great solution for many types of database scenarios, but some of the more common use cases include web and mobile applications that need a database with a high throughput, massive storage scalability, and high availability. Here are some common requirements that could indicate that RDS is the right solution for you. Do you need to support complex transactions or complex queries? Do you have a medium to high query or write rate, up to 30,000 input outputs per second? You don't need more than a single worker, node, or shard. Some of the requirements that might mean RDS is not the best solution for you include: you need massive read writes, for example, 150,000 writes per second. You have really large data sets or throughput demands. Or you have very simple get or put requests and queries that might be better suited for a NoSQL database. If Amazon RDS is not a good candidate for your requirements, you should consider one of the other database services such as Amazon Aurora or Amazon DynamoDB, which we will review in other videos in this series. When you begin to estimate the cost of Amazon RDS, consider the clock hours of service time. You are billed based on the amount of time your service is running. The physical capacity of the database you choose will also affect how you are charged. Database engine, instance size, and memory class will impact the cost running your database RDS instance. Database purchase type also has an impact on your cost. When you use on-demand instances, you pay for compute capacity for each hour that your database instance runs. There is no minimum requirements or commitments. You can also select reserve instances. With reserve instances, you make a one-time upfront payment for each database instance that you want to reserve for a 1-year or a 3-year term. The number of instances you create will also impact your cost. For example, you might want to provision multiple database instances to handle peak loads. Selecting the best storage configuration is another factor that will impact the cost of running your RDS implementation. There is no additional charge for backup storage of up to 100% of your provisioned database storage for an active database instance. After the database instance is terminated, backup storage is billed per gigabyte per month. Finally, consider the number of input-output requests that will be made to the database, as well as any data transfers. Inbound data transfer is free, and outbound data transfer costs are tiered. Depending on the needs of your application, you might be able to optimize your costs by purchasing reserved instances. Thanks for watching. We'll see you in the next video. Hello, and welcome to this Academy Cloud Foundations demonstration. In this segment, we're going to be speaking about Amazon Relational Database Service, or Amazon RDS. Amazon RDS makes it easy to set up, operate, and scale a relational database in the cloud. It provides cost-efficient and resizable capacity while automating time-consuming administration tasks such as hardware provisioning, database setup, patching, and backups. It frees you to focus on your applications so you can give them the fast performance, high availability, security, and compatibility that they need. Amazon RDS is available on several database instance types, optimized for memory, performance, or input and output. It also provides you with 6 familiar database engines to choose from, including Amazon Aurora, PostgreSQL, MySQL, MariaDB, Oracle, and Microsoft SQL Server. You can use the AWS Database Migration Service to easily migrate or replicate your existing databases to Amazon RDS. In this demonstration, we go through the steps of creating a MySQL database using Amazon Relational Database Service and the AWS Management Console. We then connect to the database in AWS using a MySQL client running on an Amazon Linux EC2 instance. So we are at the console, and we're going to be navigating to the RDS landing page. Once we are on the Amazon RDS landing page, we focus our attention on the orange button that says Create Database. We also notice how the left navigation panel has a number of items related to snapshots, automated backups, query editor, and others. These items are a little bit more advanced, and we suggest that you explore them individually to become familiar with what is it that they do, what benefit they render to you. We're going to click on Create Database. And on the following panel, we get to select the engine that we're going to be using. In our case, the MySQL engine. We get to see Amazon Aurora, MariaDB, Postgres, Oracle, Microsoft SQL Server. In this case, we use MySQL as it is a common database implementation for LAMP stacks. On the MySQL configuration, we're going to click on Next. And RDS gives us a way to be able to choose what type of use case are we going to be applying in this particular case. In our case, we're going to be generating a development and testing database. And we're going to make it applicable for the free usage tier. We're going to click on Next after that, and we get to answer some questions related to this particular database instance. Scrolling down a little bit, on the DB instance class, we're going to scroll up and select T2 Micro. That's going to give us a database engine that's actually applicable for the free tier usage. Because this is a development database, we're not going to be doing multi-availability zone deployment. We're going to leave the storage exactly as is, and we're going to be disabling the storage auto-scaling. Notice how the panel for estimated monthly cost gives you an estimate of what you will expect to pay for this particular implementation on a monthly basis. On the database instance identifier, we're going to give it a name. For master username, we're going to be selecting admin. We're going to be providing the master password and confirm it and click on Next. Following that, a number of advanced settings come into play. As far as the virtual private cloud that we're going to be using to land this particular RDS instance, we're going to select Lab VPC. The subnet group, we're going to keep the same. And for public accessibility, we already have it checked. We don't want it to be publicly accessible. We have no preference for availability zone. However, on the VPC security groups, we have pre-provisioned an RDS security group, which is actually open for the MySQL port 3306. The database name and the port 3306, everything looks good. We're not going to be using identity and access management authentication, so that radio button is selected correctly. We're not going to be using encryption. And for backup, we're going to select 0 days. We're not going to copy any tags. And we have disabled enhanced monitoring. As far as log exports, we're going to leave everything as is. And we're going to be disabling AutoMiner version upgrades. We're also going to be deselecting Enable Deletion Protection. That's all it takes. We're going to select Create Database, and that will immediately begin defining our database instance. We select DB instance details, and we get to observe the database provisioning. Initially, notice on the DB instance status, it indicates creating. We also get to observe how there are a number of CloudWatch metrics already prefabricated as far as being able to observe CPU utilization, DB connections, free storage space, memory, write input outputs per second, read input outputs per second. On the Connect panel, under the endpoint, is where we will receive, once the database is available, the actual host name that we will be using to connect. At this point, we scroll back up, and we're going to be using the refresh button as a way of having the page refresh while we wait for the DB instance status to indicate available. Okay, we now get to observe on the info that the database instance, my ACFDB, is marked as available. So we're ready to go and begin connectivity. As we scroll down on the endpoint and port, we're able to then copy and paste the hostname for connectivity to this database instance. We're going to be maintaining a copy of that RDS endpoint here on a text editor. Following this, we're going to be using the MySQL call to be able to invoke the command line interface to the MySQL database. Providing the password then allows us to begin to interact through the MySQL command line interface. We're going to be invoking some table creation as well as some data population of that table. So a total of 5 statements. The first one, create table, defines the schema, and then of course we populate with 4 names, last names, and phone numbers. All of the queries and all of the requests to the instance actually appear to be working correctly. Now let's do a small query to verify. Pasting a small query will give us the proper result. In this case, we're searching for Chris. We get first name, last name, and phone as a table. So we have successfully provisioned a MySQL database instance using the simplest configuration possible, including the database engine that qualifies for the free tier, using an EC2 instance running the Linux operating environment. We connected to that MySQL database, created a table, populated that table with data, and finally made a small query to verify. This concludes this demonstration for Amazon RDS. Thanks for watching.
Let's jump into Simple Storage Service, or S3. Amazon S3 is object-level storage, which means that if you want to change a part of a file, you must make the change and then re-upload the entire modified file. S3 stores data as objects in resources that are called buckets. Amazon S3 is a managed cloud storage solution that is designed to scale seamlessly and provide 11 nines of durability. You can store virtually as many objects as you want in a bucket, and you can write, read, and delete objects in your bucket. Bucket names are universal and must be unique across the world. Objects can be up to 5 terabytes in size. By default, data in Amazon S3 is stored redundantly across multiple facilities. The data that you store in Amazon S3 is not associated with any particular server, and you do not need to manage any infrastructure yourself. You can put as many objects into S3 as you want. Amazon S3 holds trillions of objects and regularly peaks at millions of requests per second. Objects can be almost any data file, such as images, videos, or server logs. You get fine-grained control over who can access your data by using AWS Identity and Access Management policies, Amazon S3 bucket policies, and even per-object access control lists. By default, none of your data is shared publicly. You can also encrypt your data in transit and at rest by enabling server-side encryption. Amazon S3 includes event notifications that enable you to set up automatic notifications when certain events occur, such as when an object is uploaded to a bucket or deleted from a specific bucket. Those notifications can be sent to you, or they can be used to trigger other processes, such as AWS Lambda functions. Amazon S3 offers a range of object-level storage classes that are designed for different use cases. These classes include Amazon S3 Standard. It's designed for high availability, high durability, and performance for frequently accessed data. Because it delivers low latency and high throughput, Amazon S3 Standard is appropriate for a variety of use cases, including content distribution and big data analytics. The Amazon S3 Standard Infrequent Access Storage class is used for data that is accessed less frequently, but requires rapid access when needed. Amazon S3 Standard Infrequent Access is designed to provide the high durability, high throughput, and low latency of Amazon S3 Standard with a low per gigabyte storage price and per gigabyte retrieval free. This combination of low cost and high performance makes Amazon S3 Standard Infrequent Access good for long-term storage and backups, and it's a data store for disaster recovery files. Amazon S3 One Zone Infrequent Access is for data that is accessed less frequently but requires rapid access when needed. Unlike other Amazon S3 storage classes, which store data in a minimum of 3 availability zones, Amazon S3 One Zone Infrequent Access stores data in a single availability zone, and it costs less than Amazon S3 Standard Infrequent Access. Amazon S3 One Zone Infrequent Access works well for customers who want a lower cost option for infrequently accessed data, but do not require the availability and resilience of Amazon S3 Standard or Amazon S3 Standard Infrequent Access. It is a good choice for storing secondary backup copies or easy to recreate data like the thumbnail version of an image catalog. The Amazon S3 Intelligent Tiering Storage class is designed to optimize costs by automatically moving data to the most cost-effective access tier. For a small monthly fee per object, Amazon S3 monitors access patterns of the objects in Amazon S3 Intelligent Tiering and moves the objects that have not been accessed for 30 consecutive days to the infrequent access tier. If an object in the infrequent access tier is accessed, it is automatically moved back to the standard access tier. The Intelligent Tiering Storage class works well for long-lived data with access patterns that are unknown or unpredictable. Amazon S3 Glacier is a secure, durable, and low-cost storage class for data archiving. To keep costs low, yet suitable for changing needs, Amazon S3 Glacier provides 3 retrieval options that range from a few minutes to hours. You can upload objects directly to Amazon S3 Glacier, or use Amazon S3 lifecycle policies to transfer data between any of the Amazon S3 Storage and Amazon S3 Glacier. Amazon S3 Glacier Deep Archive is the lowest cost storage class. It supports long-term retention and digital preservation for data that might be accessed once or twice in a year. It is designed for highly regulated industries such as financial services, healthcare, and public sectors. In some cases, these customers need to retain datasets for 7 to 10 years to meet regulatory compliance requirements. Amazon S3 Glacier Deep Archive can also be used for backup and disaster recovery use cases. It is a cost-effective and easy-to-manage alternative to magnetic tape systems. Amazon S3 Glacier Deep Archive complements Amazon S3 Glacier, and it is also designed to provide 11 nines of durability. All objects that are stored in Amazon S3 Glacier Deep Archive are replicated and stored across at least 3 availability zones, and these objects can be restored within 12 hours. Let's look at S3 buckets in more depth. Buckets are logical containers for objects. You can have one or more buckets in your account. You control who can create, delete, and list objects in the bucket. You can view access logs for the bucket and its objects. Also, you can choose the geographical region where your S3 stores the bucket and its contents. In the example shown, Amazon S3 was used to create a bucket in the Tokyo region, which is identified within AWS formally by its region code, AP Northeast 1. The URL for a bucket is structured like the examples. You can use 2 different URL styles to refer to buckets. The path style URL endpoint is normally used when you need to access objects. The virtual hosted style URL endpoint is used when you are using your bucket as a website for static data. Notice the difference in structure. In this example, the object preview2.mp4 is stored inside the bucket. The URL for the file includes the object name at the end of the bucket path style endpoint. When you create a bucket in Amazon S3, it is associated with a specific AWS region. When you store data in the bucket, it is redundantly stored across multiple AWS facilities within your selected region. This means your data is secured even if there is concurrent data loss in 2 AWS facilities. Amazon S3 automatically manages the storage for your bucket while your data grows. You can get started immediately, and your data storage will grow with your application needs. Amazon S3 also scales to handle a high volume of requests. You do not need to provision the storage or throughput, and you are billed only for what you use. You can access Amazon S3 through the console, AWS command line interface, or AWS SDK. You can also access the data in your bucket directly from third-party backup tools. Keep in mind that this type of access is considered programmatic access and will require that you provision a key pair for the third-party tool to be able to connect to your Amazon S3 service. The endpoints that support HTTP and HTTP access must be globally unique and DNS compliant. This means that bucket names need to be all lowercase and contain a combination of only letters, numbers, and dashes. Symbols like exclamation points, ampersands, or periods are not allowed. The flexibility to store a virtually unlimited amount of data and to access that data from anywhere means that Amazon S3 is suitable for a variety of scenarios, including static website hosting. Amazon S3 buckets can serve the static contents of your website, including HTML, CSS, JavaScript, and other files. The high durability of Amazon S3 makes it a good candidate for storing backups of your data. For greater availability and disaster recovery capability, Amazon S3 can even be configured to support cross-region replication so that data in an Amazon S3 bucket in one region can be automatically replicated to another Amazon S3 region. Amazon S3 costs vary depending on the region and the specific requests that are made. You pay only for what you use, including gigabytes per month, transfer out to other regions, and put, copy, post, list, and get requests. As a general rule, you don't pay for transfers in to Amazon S3 or transfers out from S3 going to Amazon CloudFront edge locations within that same region. Consider the following when you estimate the cost for Amazon S3. First, keep in mind that each storage class has different rates. Second, your costs will be determined by the number and size of objects stored in your Amazon S3 buckets. You must also consider the number and type of requests. GET requests incur charges at different rates than other requests, such as PUT and copy requests. GET retrieves an object from Amazon S3. You must have read access to use this operation. PUT adds an object to a bucket. You must have write permissions on a bucket to add an object to it. Copy creates a copy of an object that is already stored in Amazon S3. A copy operation is the same as performing a GET and then a PUT. Finally, consider the amount of data that is transferred out of the Amazon S3 region. Remember, the data transferred in is free, but there is a charge for data transferred out. Thanks for watching. We'll see you in the next video.
Hello, and welcome to this Academy Cloud Foundations demonstration. In this particular segment, we will be speaking about Amazon Simple Storage Service, or Amazon S3 for short. Amazon S3 is an object storage built to store and retrieve any amount of data from anywhere on the internet. It's a simple storage service that offers an extremely durable, highly available, and infinitely scalable data storage infrastructure at very low cost. S3 provides a simple web interface that you can use to store and retrieve any amount of data at any time from anywhere on the web. Using this web service, you can easily build applications that make use of the internet storage, and since S3 is highly scalable, you only pay for what you use. You can start small and grow your application as you wish. You get no compromise on performance or reliability. S3 is also designed to be highly flexible. You can store any type and amount of data that you want. You can read the same piece of data a million times or only for emergencies like disaster recovery. You can build a simple FTP application or a sophisticated web application like Amazon.com, the retail website. So S3 frees you as a developer to focus on innovation instead of figuring out how to store your data. So how do we get started? You need to have an Amazon Web Services account to access S3. I have here my Amazon account. I'm going to be navigating to the S3 console. We get to see that it's a relatively simple console with just a few items actually worth highlighting. The very first one is that the S3 console gives you a global view of all of your buckets. Despite the fact that a bucket actually needs to live in a particular region, the console provides you a global overview of all of the buckets existing, including the region in which they live. Notice this one on US Oregon, most of them on North Virginia. And as you may have noticed, a bucket happens to be the logical storage resource for Amazon S3. In order for us to create a bucket, we click on the Create Bucket button. A bucket needs to have a name that is DNS compliant. What this means is that in general, you want to focus on using lowercase letters, numbers, and dashes, and not make the name too big. The reason for this DNS compliance requirement is that the name of the bucket will actually be used on the URL that you use to access your files and your objects, and therefore it needs to be unique globally. If you forget the uniqueness of the name, or if you're not sure if the name is being used, the system itself gives you a heads up when a particular bucket name is already in use. Let's take the example for the bucket name test. That is a relatively common actual bucket name. If we click on create, you get to see the system tells you the bucket name already exists. Therefore, we need to apply some form of change to this particular name in order to be able to use it. Notice also the little I to the right, which kind of reminds you that the bucket name needs to be unique across all buckets in the system globally. And this has to do with the fact that the bucket name is being used in the URLs that then will access the bucket as well as the objects within it. Now, let's take this other example. In this particular case, the bucket name may not be in use. However, we're using uppercase letters, and the system makes an attempt to remind you of what is allowable versus what cannot be used. I'm going to name this particular bucket ACF S3 Demo. This appears to be a unique enough bucket. I'm choosing to store it in the Sao Paulo region as a way of putting it as far away from IAM as possible. Which region do you actually choose in order to put a bucket can follow a number of requirements. You can also choose a region that is remote from your other operations for geographic redundancy and disaster recovery purposes. You can choose a region that enables you to address specific legal or regulation requirements. And finally, you can choose a region that allows you to reduce storage cost. You can choose a lower price region to save money. In this case, I'm just using Sao Paulo for demonstration purposes. Now, I can choose the Create button immediately, but let's explore what kind of questions the user interface gives us as we manufacture a bucket. I'm going to click on Next. And we get to see a number of other properties that can be attributed to this particular bucket. We get to see on the top versioning, which basically keeps all the versions of a particular object on the same bucket. When you enable versioning, multiple uploads of the same file are actually retained by a timestamp. And that actually helps you be able to recover for accidental overwrites or deletion. Enabling versioning also increases the total data size that is stored in your bucket. So you need to be mindful of that, especially when it comes to billing and pricing. We see also the item for server access logging. And this is a way of maintaining a trace of the type of access that a particular bucket is actually sustaining. Tags represent key value pairs that you can use as a way of providing kind of stickers to be able to align the use of the bucket in terms of perhaps who is the owner, who the contact person is, for what purpose is this bucket being used. Object level logging, as the name suggests, is actually a trace file that keeps a record of who is accessing objects in this particular bucket. CloudTrail will be able to maintain such items. One important item about S3 is that you can enable encryption. Encryption in S3 uses AES 256 encryption, and you have a variety of ways of managing the keys that will cipher this particular item. You can have the S3 service manage the keys itself. You can manage the keys yourself as a customer, or perhaps you may want to leverage the AWS service for key management. In that particular case, you get the freedom to choose how the keys are handled. Last but not least, you can actually have CloudWatch request metrics for the usage of this particular bucket. In this example, we're leaving everything as default. The next item has to do with permissions. And following the principle of least privilege, and as it is common with most of AWS resources, basically public access to the resources that you create is sealed shut. Unless you specifically enable access to a resource, only the owner will be able to access and manipulate these items. Notice how the block all public access is enabled. We're going to leave it as is and continue to move forward. In this panel, we are reviewing the configuration, the name of the bucket, the region, the options, as well as the permissions that have been enabled by default. We're taking it as it shows up out of the box. We're going to be creating the bucket. And now we get to see ACF S3 demo bucket. If we navigate into it, you are able to examine, number one, the region in which it lives, and the properties for the bucket can actually be modified through the Properties tab. The permissions for the bucket has its own tab, allowing you to be able to block or enable public access. You can assign a bucket policy. This will be created using the Identity and Access Management Service. You can also define an access control list. This is a legacy mechanism that actually existed prior to policies being able to be used. The Management tab allows you to be able to define lifecycle for the objects in this bucket, allows you to define perhaps analytics in terms of usage for this particular bucket. Going back to the overview, we are within the bucket and we're going to upload a particular file. Notice also the button for Create Folder. A folder is actually an abstract concept in the idea of a bucket. It's not really a folder the way that we got to know it using an operating system, despite the fact that the S3 interface actually presents it like that. It's basically a logical separator for you to be able to organize files within a bucket and still follow a particular hierarchy. We're not going to create a folder. However, we are going to upload a file. When we select the upload file, we click on Add Files. I navigate to my desktop and I'm going to select my machine profile application. This is packaged in Mac format. Notice how it already registered the name. I'm going to click on Next as a way of demonstrating how, for that particular object, I am the owner. I can read, write, and modify. You can add another AWS account to have access to this. We're going to leave that as is. And notice how, in terms of public permissions, as we mentioned earlier, public access is blocked. As most things AWS, public access out of the box is sealed shut. Unless you specifically enable access, access will be disallowed for anyone but the owner. Clicking on Next, select the storage class for this particular object. And as you get to see, there is a significant amount of storage classes. Each of them actually has its own use and applicability for use cases. The standard storage class is usually the default storage for any uploads that you have. This is the more common item and is intended for frequently accessed data. Notice in the availability zone, it indicates that at least 3 availability zones are actually at play when you upload the object. And this is how S3 is able to implement high availability, high durability. Each object as you upload it actually gets copied into 3 separate availability zones, and 3 copies of this particular item exist at all times. In the event of a failure on a particular facility, you always have redundant copies that actually become available to you. Now, interestingly enough, the second is the intelligent tier. As the name suggests, this is for long-lived data with changing or unknown access pattern. So Amazon S3 intelligent tiering is an S3 storage class for data with unknown access patterns or changing access patterns that are difficult to learn. It is the first cloud storage class that delivers automatic cost savings by moving objects between 2 access tiers when access patterns change. One tier is optimized for frequent access, and the other lower cost tiers are designed for infrequent access. Objects uploaded or transitioned to S3 intelligent tiering are automatically stored in the frequent access tier. S3 intelligent tiering works by monitoring access patterns and then moving the objects that have not been accessed in 30 consecutive days to the infrequent access tier. If the objects are accessed later, S3 intelligent tiering moves the object back to the frequent access tiers. This means that all objects stored in S3 intelligent tiering are always available when needed. There are no retrieval fees, so you won't see unexpected increases in storage bills when access patterns change. So S3 intelligent tiering is for data where you don't really know the access patterns or whether they're changing and you cannot really discern them. So it is ideal for data sets where you may not be able to anticipate what the access pattern is going to be. It's all about saving you money and maintaining the object in the proper tier. S3 standard infrequent access is Amazon's S3 storage class for data that is accessed less frequently but requires rapid access when needed. S3 standard IA, as it is called, offers the high durability, throughput, and low latency of Amazon S3 standard storage class. It also provides you a low per gigabyte storage price and per gigabyte retrieval fee. So this combination of low cost and high performance makes S3 standard IA ideal for long-term storage, backups, and as a data store for disaster recovery. The S3 standard IA storage class is set at the object level and can exist in the same bucket as the S3 standard or S3 one-zone IA storage classes. This will allow you to use the S3 lifecycle policies to automatically transition objects between storage classes without any application changes. This particular storage category is also used by the intelligent tier. S3 one-zone IA storage class is an Amazon S3 storage class that customers can choose to store objects in a single availability zone. S3 one-zone IA storage redundantly stores data within that single availability zone to deliver storage at 20% less cost than geographically redundant S3 standard IA or S3 standard, which stores data redundantly across multiple geographically separated availability zones. S3 one-zone IA offers 99% availability. But unlike the S3 standard and S3 standard IA storage classes, data stored in S3 one-zone IA will be lost in the event of an availability zone destruction. So you need to be able to reproduce the data that is stored in S3 one-zone IA. This is usually thumbnail pictures from a high-resolution picture catalog or data that normally lives in its natural form someplace else, and you use the S3 one-zone IA storage tier as a way of maintaining some variation copy, usually a smaller version or perhaps a lower resolution. Glacier Deep Archive are actually used for cold permanent storage. Glacier, as the name suggests, is frozen storage. It gives you a significant price reduction in terms of store. However, it comes at the expense of having high latency, high wait times before you actually retrieve the object. Reduced redundancy is not recommended to be used. It's more expensive than any of the other tiers, and it is a storage class that is being deprecated. Moving forward on this particular panel, we get to review the permissions, and we finally get to upload our object. The panel indicates a progress report of the upload until we finally get it accessible. At this point, we see the file being uploaded. We are within the bucket ACF S3 demo, and we get to see the different tabs for the bucket configuration. If we select the actual file, we then get to be able to inspect the idea of the latest version. We left versioning unavailable for this particular bucket as well as this particular object within the bucket. However, you get to see the metadata that is associated with the file. We call S3 object store despite the fact that you're actually uploading logical files, they become objects simply because these files get wrapped around with additional metadata like owner, last modified, storage class, whether server-side encryption is enabled or not, and that turns the file into an object. More importantly, also notice the object URL in order for you to be able to access it using an API or using a web browser from anywhere. By virtue of the permissions that we actually use, which are the default permissions, public access to this particular object is actually disabled. The first thing that needs to happen is that we need to enable public access on the bucket. We're going to do that as an exercise, although the best practice is for you to be able to determine who will have access to this and manufacture a bucket policy that will allow access only and exactly as you need to. Public access to S3 resources is frowned upon and usually causes more harm than good. However, for the sake of an exercise and to demonstrate the built-in protections that the system has, let's go through the mechanics of habilitating public access. I'm going to navigate to the bucket that contains the object. And in the particular bucket, I'm going to select the Permissions tab. And notice how there's a full set of block public access settings. I'm going to click on the Edit menu and then uncheck Block Public Access. Please note when I click on Save, the system actually asks me to confirm that this is in fact what I want to do. This is a reminder that updating public access settings will have an impact on the bucket and all of its contents. I use the word confirm and verify that that's in fact what I want to see happen. Now I have enabled public access at the bucket level. So now the blocking of all public access has been disabled. I can navigate back to the Overview tab. I can select the file, and then on the actions, I can select Make Public. The system reminds me that everyone will have access to this particular file, and I confirm. At this point, I will expect to be able to navigate back into examining the file metadata. And when clicking the item, I will expect a download dialog to permit me now to be able to download the file. There is a significant amount of other features that are worth exploring with S3, especially when it comes to properties. The idea of versioning, the idea of server access logging. You can use an S3 bucket to be able to host a static website. A static website is a website where no dynamic information is generated. This could be just static HTML pages, JPEGs, even perhaps videos or pictures. And it does not require for you to manage a web server or anything of the sort. It scales up and down as needed and can be easily configured. In terms of management, there are a number of other properties that you can set up. Notice default encryption, as well as things like events, where the S3 bucket will generate an event, perhaps to activate a Lambda function when an object is actually uploaded, and the idea of who pays when a particular object is associated. This is more an introductory demo for Simple Storage Service. I hope you found it useful, and thanks for watching.